Hello, welcome to this YouTube tutorial where I'm going to show you how to solve 10 questions from the Chapter 6 unit, Radical Expressions and Functions. To start, I'm going to explain how to solve an equation from Lesson 6-1, Operations on Functions. Solving this equation is pretty self-explanatory. First, you do the whole f of x equation, 6x plus 2, and you put it over the equation of g of x, which is 3x minus 1. This expression right here would be the first part of the answer for this question, but you need to find the second part of the answer, which is what this bottom part would equal if it was 0. Because if the bottom part equals 0, then the equation is not possible to solve because you cannot divide anything by 0. So in order to find out what x cannot equal, you put 3x minus 1 and set it equal to 0. Then you solve, moving 1 to the other side, you get 3x equals 1, then divide 3 on both sides, and you get x cannot equal 1/3. So the final answer for this question is the equation part, which is 6x plus 2 over 3x minus 1, and the second part of what x cannot equal, which is 1/3. For the next question, I'm going to explain how to solve f times g. And in order to do that, you're going to plug in this whole f of x equation into f, which would be 2x plus 3. And then you would plug in g of x where g is, which would be 5x minus 1. And then in order to solve this, you just use the FOIL method, which is the first terms, which would be 10x squared. Then you do the outer terms, which is minus 2x. Then you do the inner terms, which is 3 times 5x, which is 15x. And then you do the last terms, which is 3 times negative 1, which is negative 3. And then you combine like terms, you get 10x squared plus 13x minus 3. And that is the final answer. Now we're going to move on to lesson 6-2, inverse functions and relations. For this third question, I'm going to show you how to find the inverse of y equals 6x plus 2. Now there are two ways you can solve this. You can either 1, use algebra, or 2, you can just use logic. I'm going to show you how to use algebra. So the way you can find inverse for an equation like this, you just flip your x and y. So it would be x equals 6y plus 2. And then all you have to do is just solve for y. So in order to do that, you have to do minus 2 from both sides. And you get x minus 2 equals 6y. And then you divide both sides by 6. And you get x minus 2 over 6 equals y. But make sure whenever you write this, you have to add the notation of the negative 1 squared to show that it's an inverse. The next example I'm going to show you how to solve is by proving that two functions are inverses of each other. The first way you can find out if these functions are even inverses of each other's is by just finding the inverse of 1. To find the inverse of this, you can do as we did in the other equation, which is setting x equal to 5y plus 4. And if I subtract 4 from both sides, and then I divide 5, I would get x minus 4 over 5 equals y, which is the same as this equation. But that doesn't necessarily prove that these two functions are inverses. The way to prove that these two functions are inverses of each other is to do the x of g of x notation. And if you solve this out and you get x alone by itself, like 1x or just x, then that proves that they're inverses. And the way to solve this is you write out this whole f of x equation, but then you plug in the whole g of x into the x variable. So it would look like this. 5 times 1/5 x minus 4/5 plus 4. Then, multiplying this out, you would get 5 over 5x, which is 1x. 5 times negative 4, which is negative 20 over 5. But if you simplify that down, it would be negative 4. And then add 4 to that because it's on the outside. Then, minusing 4 and adding 4 cancels each other out. It equals 0, and you get 1x. And this proves that these two functions are inverses of each other. Moving on to the next example, I'm going to show you how to graph this equation from lesson 6-3, square root functions and inequalities. Step 1 in this equation is to find the domain of y equals the square root of x plus 6. And in order to find that, you get from inside the radical, which is the radicand, and you set that equal to greater than or equal 0. Then solving this out, you get x is less than or equal to negative 6 because you subtract 6 to the other side. So now that we know that this is our domain, we start from here and make a little chart with our x and our y coordinates. So starting with negative 6, you plug that back into this equation. And if you plug in negative 6 plus 6, you get 0. And the square root of 0 is 0. So that means our first y coordinate on this graph would be negative 6, 0. From there, you just go and check each number. If I put negative 5 into this equation, would I get a square root that works out evenly? So let's check. Negative 5 plus 6 would equal 1. Square root of 1 is equal to 1. So yes, that would work. You can put negative 5, 1 into your graph for this equation. If I tried to do negative 4, I would get the square root of 2, which would equal out as in a messy decimal that wouldn't be fun to graph. If I did negative 3, I'd also get a bad square root, a bad decimal number. If I had negative 2 though, which is negative 2 plus 6, that would be the square root of 4, which equals 2. So that works out. So I can do negative 2, and whatever I always get as the equals will be the y. Now let's do one more x value so that we can make this graph. If we did negative 1, that would get a square root of 5. That wouldn't work that well. If we did 0, it would get a square root of negative 6. That wouldn't work out well. If we did 1, that would get a square root of 7. If we did 2, that would get a square root of 8. But if we did 3, that would get us square root of 9. And we know that the square root of 9 is also 3. Then graphing goes as follows. Negative 6, 0. Negative 5, 1. Negative 2, 2. And then 3, 3. And then just connect your graph like so. For the next question, we're going to go to lesson 6-4, nth roots and rational exponents. So for the first question, I'm going to show you how to simplify this radical right here. To start, you're going to write out, this is one way you can solve it. You're going to write out all the factors that you know, like simplified down, that can go into 32. You can do this by making a factor tree because I know that 4 and 8 go in, and you can simplify that down to 2 times 2, and 8 can go to 4 times 2, and which can go to 2 times 2. So we know that there would be 1, 2, 3, 4, 5 2's. Writing that out would look like this, just writing all the 2's, and then you do the same for A, which would just be 15 A's, and then you do the same for B, which would be 10 B's. Though this is a very tedious way to find the answer for this expression, it does work. By finding every time, since this is to the 5th, you're going to find how many of each factor is there 5 times. So there are 5 2's, which means you can circle that. Then you do 1, 2, 3, 4, 5. 5 A's, 1's, 1, 2, 3, 4, 5. The second time, 1, 2, 3, 4, 5. The third time, which means you're going to have a 2 and an A to the third on the outside. And then last, you can do the B's, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. Which means I have 2 sets of B's that go in 5 times. I have 3 sets of A's that go in 5 times. So then I'd write B to the 2nd power. A different way you can solve this, which is definitely the more easier way, is by using your calculator. So first, since we know that to unsquare rooting it by the 5th is the same as raising 32 to the 1/5 power. And that gets you 2. That's how you can find 2. Or you can enter a 5 in, hit the second key, and then hit this, like the caret key, and then put in 32. And that also gets you 2. That only works though for whole numbers, not for exponents. But for exponents, you can do whatever the exponent is. So this is 15, and divide it by this out here. So 15 divided by 5 is 3, which is how I got a to the 3rd. B to the 10th divided by 5 is b to the 2nd. So there's 2 ways you can solve that, by writing it out fully or using your calculator for part of it and then dividing out the rest. For the next section, I'm going to show you how to add radicals by showing you an example from lesson 6-5, operations with radical expressions. So for this, obviously you cannot add these two together because they are unlike terms. So what you're going to have to do first is unsquare these or simplify them down into their simplest terms. For 72, there's 9 and 8, like this. And since I know that 9 can simplify down into 3, I'll leave that out. And I know this can go into root 2 and root 4. And this obviously can simplify down into 2. So I can do 3 times 2, which is 6. Leave that root 2. And then I'd have to times this 6 by the 7 since they're both on the outside. So 7 times 6 is 42 root 2. Then since we did root 8 over here and we know that it would equal 2 root 2, you can leave it like that. But then remember to times the 5 by the 2, which leaves you with 10 root 2. Now let's move this over here to make it more cleaner. We have 42 root 2 plus 10 root 2. Now, since these two are like terms, we can add only the coefficients together, not the radicals, because you cannot add just the radicals together like that. You can only add the 42 and the 10, which gets you with 52 root 2. And that is your final answer. For this next question, we're going to do a combination of adding and subtracting. And for the first step, you're going to want to simplify all your roots down. And to save time, I'll just cut to the next part of me simplifying them. 6 root 18 simplifies to 18 root 2. 3 root 56 simplifies to 6 root 14. And 15 root 2 is already simplified, so you bring that down. Then you can only combine like terms. So I have to combine 18 root 2 and 15 root 2. And whenever I subtract those, I get 3 root 2. And then I can't add these together since they're not like terms, and this cannot simplify down anymore. So I just leave it as is. I just add 6 root 14, and that is your final answer. For the next example, I'm going to show you how to solve this equation from lesson 6-6, nth roots and rational expressions, which, yes, is the same exact as 6-4, but this involves the division. So in order to do this, you can do it one of two ways. One, you can bring this 16 out, and this to the third 3 over 2 power is the exact same as this right here. And that would be 16 to the third, cubing it by like square root of 2. And then 16 to the third is equal to 4,096. And then solving this out would equal you 64. Then you can do as follows. 192 divided by 64, which equals 3. Another way you can solve this is by plugging this 16 to the 3 over 2 power into your calculator. So we can do 16, and then you can do up to the 3rd over 2 power. That gets you 64, which is the easier way of doing it. And you can also do 16 raised up to the 3rd, 496, and then do the same as you did in one of the previous equations, and get 64 again. Okay, I forgot to mention that was question 9, but now for our final explanation, I'm going to show you how to solving for x when solving radical equations and inequalities from lesson 6-7. To start, you're going to subtract 9 from both sides in order to get this radical by itself. That would get you 5x plus 6 equals 6. Then, to get this radical out of here, because it's really hard to divide with that, you're going to square both sides, because squaring will cancel the radical out. When you square both sides, the radical will be gone, so it'll just equal 5x plus 6, but then you have to square 6, which gets you 36. Then, just subtract 6 from both sides, and you get 30 equals 5x, and then divide both sides by 5, and you get x equals 6, and that is your final answer. Thank you so much for watching. I hope that this tutorial can help you as you try to solve questions through Chapter 6, Radical Expressions and Functions.